Starting now. Design parameters given. Number one, they gave us that the excavation of the staircase foundation below natural ground level is equals to 300 millimeter with a width of 450 mm. That is given as this. This is the natural ground level. This dot I put here, NGL. And it's given that the excavation depth is 300 millimeter, which is this. I wrote here. Now they gave us a width of 450 mm. That means from here to this depth to this length here is 450. That will be our width. Now they say provide that the 12 mm diameter reinforcement placed at 175 center to center for reinforcement required. Make reasonable assumptions where necessary. Okay. Which one? Which down, please? This natural ground level. You mean which one? Yes, 450. That is from here. I don't know. I don't know for the natural ground level. I'm just you can use any. Yeah. It's undefined. No dimension because it's a natural ground level. They only gave us the width of the staircase. The height is 300. The width is 450. I see. That's why I put 450 here. Now we are going to do this thing. That is from this foundation depth of the staircase. Now, when you're drawing this staircase, see how it's going to be like. When you're drawing this staircase, you count 3 risers from the top. 1, 2, 3. That is where you're going to place your top reinforcement. You draw it down. Yeah? Your reinforcement, those top reinforcement at the staircase, you count 3 threads upwards. That is 1, 2, 3. Then you draw your reinforcement downwards. Then you do your foundation depth. But me, I'm assuming a concrete cover. I'm assuming a concrete cover of 30. So from here to here is 30 when you're doing your AutoCAD. So I'm drawing my reinforcement to reach here, stop here. That means they say make any reasonable assumptions here necessary. So I just assume that my concrete cover is 30. I can use 25. I can use any other number again. That's what I'm doing now. Now I'll draw my staircase from here. Why this other part is 3 threads downwards. 1, 2, 3. This is my third thread. So starting from here, I'll draw my reinforcement. I'll draw my first reinforcement here from this top. It will be like that. I seen this bottom reinforcement. It will turn to top when reaching to the slab. It will be like this. Then from this slab, okay, to cut here, there should be an opening. There should be an opening around this middle part. Yes, the concrete cover is 30-30 from the slabs. Then I'll still draw another this again. Then I'll still draw another reinforcement. This is my bottom reinforcement will turn to drop. So this is my top reinforcement, which is like this. Yeah? Yes, I'm breaking because this is another different reinforcement altogether. Breaking space. As no measurement, no measurement. $50. That is what Amadi said. That, foundation minimum. Okay, I'm assuming a concrete cover of the foundation 50. Distance, we are assuming, okay, let me put it here. Assumptions made. Assumptions made. Our foundation concrete cover. Hmm? I'll show you how to plot it. So this will be our concrete cover. So when designing this particular this now, which one? This one here. This my bottom reinforcement is to turn to top at this slab. We'll get to there when you are doing this one for the plan view of this. I'm starting with this first so that you guys won't be confused. This bottom here turn to top when reaching to the slab. I, why this other one, this bottom will turn to top when going down. For the three risers, up. You mean this one? Yes, that's what I'm talking about. This top reinforcement is to turn to bottom when going down. You understand? That's what they gave us in this thing. Normally, it's normal three riser. I mean, three threads. You do it. You do normal three threads. Then you draw your reinforcements here. So we are working on this. Remember, these are concrete cover. Concrete cover is 30 millimeters. So the spacing when you're drawing it on AutoCAD, you will draw a straight line. Then offset 30 to get your distance. I'll get into that later. Now, in this now, they gave us 450 as the distance. Yeah? I can just indicate it. You can put it for yourself. There's no space to write it. So I'm just, yes, it's 50. So from here to here is 52. Now, I want to calculate the number of reinforcement that will be placed into this reinforcement here, this top reinforcement. How we are going to do is, how we are going to do it? How we are doing it is like this. 50. You remember the width they gave us was 450. So we are going to do it like this. 450 minus 50 minus 50. Because we are cancelling out this 50 and this other 50 now. Divided by 175. 175 reinforcement, diameter of reinforcement given spacing plus 1. What will be the answer? 3. So 3 bars. So I'll indicate here. This is my first bar. 1, 2, and 3. I don't know if you guys can see it. I see it. 1, 2, and 3. Now I'll do for here. This top one too. So what I'm going to do, they gave us a excavation depth of 300 millimeter. So I'm doing it like this. Number of reinforcement. This bottom reinforcement is 50. So I'll do 300 minus 50 minus, okay, yes, that's the excavation height again. No need. Or okay, minus this concrete cover. Also be a little bit spacing. 30 divided by our 175 plus 1. What are we getting? Yeah? Because of this reinforcement here, there's a small, I didn't draw this thing well because normally a concrete cover, because of this concrete cover, this little concrete cover that's separating this top reinforcement. That's why I'm minusing by 30. Yeah? For normal foundation, is 50 we are working on. But for the waste and slab concrete cover, it's 30. The foundation from here to here is 50. Here to here is 50. That is for the foundation. Why for the waste and the slab concrete cover we are working on is 30. From here to here is 30. So it's 50 minus this 300 minus 20. Just like that. That's how we got. And we are getting 2 bars. So that is from this first top here, which you have already gotten here and here. So only 2 reinforcements you are putting here. Now from this top is like this. From this top is 3 threads they are giving. That is 3 times, no, 3 threads. No, normally 1 thread is 300. 300 millimeter. That is this 900, yeah. 3 times 300 risers divided by 175 plus 1. What are we getting? Who's calculating now? Six bars. The three. The three threads. One, two, three. And we are getting six. One, two, three, four, five, and six. This one that we have placed earlier. And same goes for this because of this thing. Still three. One, two, three, five, six. So that is our reinforcement. Now we'll solve for the number of threads, number of reinforcement that will be on this slanted height here, which is like this. Let's do the duster. Yeah? The dots. Oh, we'll do for everything. Everything. See this slanted one. We have not even done for this one. Mm. Yeah? So it's like this. First to get the number of reinforcement in this slanted height. This slanted height of our staircase now is going to be like this. They gave us 7 threads. 7 threads, that is one thread equals to 300 meters. So we'll just put it, indicate it as 7 times 300 plus, they gave us 8 risers at 150 meter. 8 risers, that's 8 times 150. Everything all squared. And you get your square root. What? Give me this answer. What will be the total distance? Yes. 8 risers. If you count these things, 8 risers. And if you count the threads, it's 7. 7 threads at 300 meters. Just call it 280 equals to 2418.68. That means he's trying to tell us that the distance from here to here is 218.68. Now we divide it by our spacing they gave us here, which is 175. 175 plus 1. What are we getting? 13. 13.8. That is equals to 17 bars. 15. Okay. 15. Okay. Branson, what do you say? So we are getting 15 bars. So we are going to plot, we are going to draw our reinforcement as 1, 2, 3, 4, 5, like that up to 15. Just like that. Dot, dot, dot. I don't know, is anybody confused up to this point? Yeah? Okay, the square root. The square root. Given that in the equation, they gave us 8 risers. If you count this things, 8 risers. And no, 1 riser is equals to 150 millimeter. Then they gave us 7 threads. And 7 threads, which is 1 foot, is equals to 300 millimeter. Substituting this value, that is 7 times our 300 millimeter all square plus 8 times our 150 millimeter all squared. You put them in a square root, you get this distance. This distance is our starting point, our distance from here to here. That is our distance. That is this 2418. Then you divide it by the number of spacing, 175 plus 1. Yeah? Yeah. The number of spacing is given in the equation 175 mm. 15 dots all between. Now they give us this thing here. From this particular landing, they give us the distance. The distance from the landing is 1,000. I remember our concrete cover is 30. Y here is also 30. You're going to do 1,000 minus 30 minus 30. divided by 175 plus 1. What are we getting? The Remember that this has 1000 land is spanning from here to here. And the assumptions we made was that our waste and our slab concrete cover is 30. That means from here to here is 30. Why from here to here is 30? So if you do 1000 minus 30, that will give you your distance, like the reinforcement distance. So you do your spacing, like you divide it by your spacing plus 1. So what are we getting? Number of bars, what are we getting? 6 bars. So you do like this. 1, 2, 3, 4, 5, 6. Why this one? And remember the waist we are working on is supposed to be 150 millimeter. Another assumption should make that our waist should be 150 millimeter. That means from this span to this span is 150. 150 or 200. That is the length of the waist. Um, 150. Here will be 6 and here will be also be 6. Have you guys written the calculations down? Have you guys written the calculations down? You are done with the section. I just want to draw this thing like for the plan view. I want you guys to understand this thing. Yeah? Which one? Yes, yes. From this part to this part, this part. Yeah. I know that from here to here is 30, but also this length from this length is 30 too. And from here to here is 30. Just like that. So, are you guys done with the calculation? Look at this. If you look at this top reinforcement here, this will be our T1. From this our foundation here, we indicate it like this. Mm. Indicate it here. And what do we get here at this top bar? We got no, because this part, this reinforcement represents the foundation, this span of the reinforcement span, like from the thread down to the foundation, it represents that that is this 3 plus this 2 plus the 3. That is 6, 7, 8, 9. We are getting 9 this in reinforcement. So I'll indicate here. I'll draw my line. When drawing to AutoCAD, use a thin line. Use thin line to draw this thing. I'll put here as my donut and I'll indicate. Number of reinforcements for this part is what do you get? 9 Y12 bar mark 01 at 175 mm center to center T1. That will be our reinforcement here. Now, when solving for our B1 and our B2, is different thing, like is a totally different thing from slab. Like how will I put it? You know that normal B1 is parallel to the shorter span. Like if I draw this particular reinforcement now, I'll just indicate here is B1. But it's different. It's different from staircase. So I'll just indicate, I'll draw a reinforcement here. Thick lines. This will be my B1, which is spanning from here to here. That is this 1000 divided by 175 plus 1. That will be my B1. So what are we getting? T1. I'm just showing you how we got. We are just starting from here. Yeah? Which one? The 9. Okay. Let me show you. Remember that we got 6 here, 6 reinforcement for this top, and we got 2 here. That's like this 6 is part of the 2. So if you count 1, 2, 3, 4, 5, 6, those two, 7, 8, 9. That's how we got 9 reinforcement. Why 9 Y12 at bar mark 175. That's how we did it now. Now these are B spanning from here. I mean, okay, see where it's spanning from. Sorry, I made one mistake. I made one mistake here. This is not supposed to be 9 because this reinforcement here is spanning from here to here 1000. So that is that 1000 divided by 175. We got 7 bars. So here is supposed to be 7 Y12. The same thing goes from this because it's spanning from here to here 1000, making it here 7 Y12 at bar mark 2, 175 mm C to C. This will be our B1. So this will be our B1. Now for our B2, at, hmm? Yes, because it's spanning from this part to this part, which is that 1000. 1000 divided by the spacing plus 1. That's why we got 7Y12 as this. You understand? It's spanning from here to here. This 3 thread. Oh, wait, I'm getting to that. I'm getting to that. No, 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 I'm getting to that. Now we are working on our B2 now. Our B2 is like this. The number of rods spanning across these reinforcements now. The number of rods spanning across this reinforcement. So you already know that this is our middle part. What do we get as our middle part here? What do you get? Hmm? Which one? Which one? What do you get? I mean from here to here. What? How many number of rows are here? Yeah, that's square root. What do you get? 15. 15 bars. I'll write 15 here. 15 bars. Sorry. Then this reinforcement, this top reinforcement, you got 6 bars. And this back and bottom, you got 6 bars. Plus 3. We indicate it. Plus 3 bars. If you add them together, what are we getting? If you add 15 plus 6 plus 6 plus 3, what are we getting? 30. So this is our B1 here. That is spanning from here to here. Okay, sorry. Yeah. This is our B1 spanning from here to here. If you indicate it, we are getting 30 Y12 at bar mark 3, 175 mm center to center B2. You understand from this point? Hmm? Which one? The second is still the same thing because they are both spanning from this 1000. Are you not seeing it? Because they are both moving from here to here. That 1000. This one too is also moving from. Are you even seeing it? Where it's. Um, I come. We now. I come. Let me draw it way. I see it now. This button reinforcement, which is this, is spanning from this 1000 here, 1000 and 1000. And this one is moving, it's like the same line with this button reinforcement here. So they are both spanning at that 1000, 1000. And if you do that 1000 divided by 175, we are getting as 7 bars, which is 7 white wolf. You understand? No, our B2 is those dot 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 you got here for both the top and bottom. That's why we added this top, this 6 plus 6 plus this our bottom here. Those top and bottom. Uh, the 3 is from this foundation depth here. That's what we use to add to get our, what we get, 30 white wolf. Our T1 is this top here. That donut. Yes, let me indicate it. Our B1. Our B1 is this. I see it. So our B1, if you're cutting this thing into half like this, if you cut this part into half, what are we seeing? We are seeing half of this, like it will be like this. That's why I draw the sectional view first, which it will look like this, obviously. Look like this. That is what you're trying to think, that these are B1. Yes, these are B1, which is spanning from this, from here to here. You understand? And this our B1 turned to a top reinforcement when moving towards this slab, which is 1000. So when drawing the sectional view, it will be like this: dash, 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 then a hook, dash, 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 because it's indicating that this turned to a top reinforcement. So when I want to draw it like that, I'll just do a span. This reinforcement is moving from here to here, which is 1000. So I'll just draw out my colored line, put a reinforcement, indicating that this reinforcement here. After you guys are making noise, I'm coming. I'm coming. This our bottom reinforcement turned to top like this. So what I'm trying to indicate that this how it will look like. I think this our bottom reinforcement is a continuous line. When it moves to this landing, it turns to a dashed line, a top reinforcement. That's what it means here. And it's spanning from here to here. And this distance from here to here is 1000. So 1000 minus 175 plus 1. We're getting at 7 white wall. But remember, these are reinforcements here. It's same thing. Like it didn't cut with this top reinforcement. It didn't cut. So it will still be the same bar mark. So we'll be working on 7 white 12 at bar mark. What was this again? Um, bar mark 2. So this will be our bar mark 2. I'll write here, indicate here is 7 y 12 bar mark 2 at 175 mm center to center. This top reinforcement is T1. So I'll put here as T1. Do you understand? You understand this part? This 30. You understand this 30? There's something you're supposed to do again. This B2 is supposed to be, remember that we added this our top and bottom reinforcement to give us that 30. So instead of B2, we just put B2 and T2, which is given as this. Just as not to confuse guys. You understand? So which part do you not understand? You understand this part? Remember that this is our bottom reinforcement. This part is our bottom reinforcement, which is this part here. Now, when moving to the landing, turn to a continuous line. This top one, I think it turn to a continuous this thing. That's why it moved like this. Now, what is and it's spanning from here to here. And what is this what is the span distance of this landing? 1,000. 1,000 divided by 175 plus 1. You got the 7 distance. Now, remember that this bar mark here, this continuous, this B1 was bar mark 2. And this part didn't cut, it bent towards this landing. It will still be same thing as bar mark 2. That's what you indicate here, bar mark 2. But instead of B1, it will change to T1 because it turned to top reinforcement. Okay. We'll do one for we'll do for this section. This part is a bottom reinforcement, which is B. That will be our B1. And that B1 will still be the same thing as our T1 because it's spanning at that 1,000 millimeter. And it cut. So I'll put here 0.4 Bama for 175 mm center to center. B1. You understand? Okay, move. Now this is our top. Okay, this is our bottom reinforcement. We'll turn to a top reinforcement here. So we're going to put a dash, 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 dash. And it will still be the same thing. The bar mark will be the same thing as this bottom reinforcement. And the bottom reinforcement will go to here as 0.4. But if you draw out a colored line indicating that this top reinforcement, which is here, will still be that 7Y12 at bar mark 0.4, which is what we're getting at bar mark 0.4 at 175 mm center to center T1. That's how we got the top reinforcement for this. Same thing up here. So we are done with this section. Like for the plan view of this is how it will represent. This is how the thing will look like in the plan section of this. We are done with this section. Like how to draw it on the plan view of this. This is how the thing will be like when you're drawing it on the plan.